Hello everyone, we're Lancer Modular Consultants and we'll be presenting to you our project about the design of a modular residential building. To begin, we know that there is a housing crisis that currently exists throughout Canada. Utilizing modular construction to build residences faster and cheaper is one way to solve this crisis. Our task was to design a residential building in Windsor, Ontario using modular construction while keeping costs down and efficiency high. Our building was designed to have 3 floors consisting of 36 residential apartments, 2 elevators, and 8 miscellaneous rooms for future use. We began the design by simultaneously completing the module and column layouts using AutoCAD and determining the building loads such as dead, live, snow, rain, wind, and seismic loads. Then we completed the 3D model of the building using StatPro. From there, we selected final member sizes and began work on the foundation. This was followed by designing the connections, shear walls, and studs and tracks. The codes and standards we used for our design were the Ontario Building Code for the loads, AISI S240-20 for the shear walls, CSSBI 58-2018 for the cold form steel studs, CSA A23.3-14 for the concrete foundation, and CSA S16-14 for the steel members. Now Elvis will talk about the module layout and the vector block connection system.
Many factors needed to be taken into consideration for the final design to be successful. Due to the modular constructing approach taken for the project, one of these factors included the module layout. This layout was dependent on the architectural plan, max module size, as well as the constructability considerations. With these factors affecting different aspects of the design, multiple module layouts were constructed. The optimal design displayed on the screen consisted of 14 unique module types, 7 for the first and second floor, and 7 for the third floor. The 7 unique module types on the first and second floor were distinguished in terms of their plan dimensions, whereas the third floor, which held the same plan dimensions as the first floor, were distinguished in terms of the beam sizes used. Type 7 module is a flat pick designed for the corridor of the building. An important aspect when talking about modular construction is its standardized vector block connection. In the diagram shown in the bottom left corner, the upper vector block of the lower module, highlighted in orange, is connected to the lower vector block of the upper module, highlighted in blue, with 2 tension bolts. In between them lies a gusset plate, highlighted in green, which is used to connect and transfer the load and shear between 2 adjacent modules. A 90-degree connection is generally the typical connection used, but in certain cases, such as the ones circled in red, a 180-degree connection is utilized. Here is Marwan, who will speak about the foundation design of the building.
After analyzing the soil strength and the load applied on the soil, shallow foundation was selected. In shallow foundation, two different types of foundation were used: wall footing to support the boundaries of the building and isolated footing to support the internal loadings coming from the column. This design was altered many times due to the code requirement that needed to be met. The working space available for the design as certain designs caused overlapping, which is not allowed, as well as construction cost consideration. Isolated footing required less material with resulting less cost. The isolated footing was proposed to be 1 meter in length with 1 meter in width and 0.5 meter in thickness. And the wall footing was proposed to be 1 meter in width with 500 millimeter in thickness. Through analysis, these designs were adequate in safely transferring loads from the superstructure to the underlying soil. Here is Tajik, who's going to talk about structural drawings.
Here's the structural model that was constructed using StatPro. Analysis of the model was used to determine the final structural member dimensions as seen in the member table below. The width and height of the members is standard in all Z modular modules, however the lowest thickness that provided structural stability was determined to be a quarter inch, or roughly 6.5 millimeters, using the structural model. Once all the design components were completed, a cost analysis of the structure was conducted with the breakdown present in the table below. The total cost of the project amounted to $7.95 million. To conclude, throughout the design, we were able to minimize our construction time, with completion of the building, including manufacturing of modules, foundation works, and structure assembly, taking an estimate of 35 days. Thank you for listening to our Capstone presentation.